Hello everyone, welcome to mentorbuddy.com. This is your mentor Gurvansh, and today we are going to learn about EDA and data pre-processing in ML. So whenever we have any kind of data set and problem statement in machine learning to solve, we always start by analyzing the data and then pre-process that particular data set for our machine learning model to train on it and then produce results with it. The process of analyzing our data is known as exploratory data analysis or EDA, and then we perform some different techniques to pre-process our data. Now guys, the EDA which I am talking about right now is practically used to identify which of these data pre-processing steps or techniques we need to perform on our data set in order to make it usable. So as you guys can see over here, the data pre-processing is one of the most useful step or most important step in any kind of machine learning problem solution. It doesn't matter which kind of algorithm you are using, supervised learning algorithm, unsupervised learning algorithm, reinforced learning algorithm, it doesn't matter. Data pre-processing is necessary and the most important step. Now the data pre-processing is just a collection of few different techniques. There is no particular sequence to do them. There is no importance of doing all the techniques. It's just that it is just a collection of different techniques which we perform on our data. And what is EDA then? And EDA is also a set of techniques which we perform on our data to identify which of the data pre-processing step we are going to use, right? So here, as I have written, there are different data pre-processing tools and we use them depending upon the data set we have. Our first implementation will be with all of these tools. After they are done, our data is processed for our actual machine learning algorithm to work on. Now in the data pre-processing, we start by importing the most basic or most generic libraries which we need for any kind of algorithm, which is NumPy library, Matplotlib library, and Pandas library. The Pandas library is used to import the dataset and work on the dataset as a data frame. The NumPy library is used to work on the dataset as a numeric Python array, and the Matplotlib library is used to plot any kind of graph or do the visualization of our dataset. Next step in data pre-processing is that we import the dataset from the folder in which we have stored our dataset. Now guys, all of these steps are done using any IDE. You can use Spider, you can use PyCharm, you can use IDLE, you can use Virtual Studio Coding, you can use Jupyter Notebook. Here in our sessions we are going to use the Jupyter Notebook for our processing. So as I was telling you guys, the first step is to import the dataset, whichever dataset you have to use to solve that particular problem statement. When we import that dataset, we have to identify whether that dataset belongs to supervised machine learning, unsupervised machine learning, or reinforced machine learning. The reason here is that if that dataset belongs to supervised machine learning, we have to separate the X and Y from the dataset. X is a common term which we take for all the input features or all the input variables. Y is the common term which we take for the output column which we are looking for in case of supervised learning. In case of unsupervised learning and reinforced learning, there is no such thing as Y, so we only have X. That is why I said that we need to identify whether we have an output column in our dataset or not. Next data pre-processing step is taking care of the missing data. Now The ML algorithm which we are going to use cannot process a missing data. If there is a data missing, the algorithm will produce an error. Now, when we take care of the missing data, we can use two methodologies. First is to ignore the missing data or to replace the complete row having the missing value, or to replace or impute the missing value with a most common value, which can be mean of the column or median of the column. Next technique is that encoding the categorical data. Now, first of all, we need to understand what is the categorical data. The categorical data directly means the string values which we have in our data set. Like as you guys can see on the screen, we have four columns here: country column, age column, salary column, and purchased column. The country column has string values, which are the country names: France, Spain, Germany. And the purchased column has two values, no and yes. Now, when you guys see these string values, they are repeating, right? France, Spain, Germany, then there is Spain, then Germany, then France. Because we have repeating string values, they are known as categorical data, because now they are forming the categories, that this row belongs to France country, this row belongs to Spain. In the same way, in the purchased column, we have repeating no and yes, that is also forming categories of whether the person has purchased the product or not purchased the product. Since our machine learning models cannot operate with the categorical values, we have to convert them into numeric values so that it can be processed. Otherwise, we will get a error. Okay. Moving on. So this is how the output of the categorical data looks. Moving on, guys, whenever we have a supervised learning algorithm, as I have told you, in supervised learning algorithm, we have a training data, we have a test data. We need to break our original data set. Specifically, we need to break our original X and Y into training and test data, so that first we can train our model, and then using the test data we can test the model, that how much accuracy we are getting from it. The data set from the previous step is then further divided into training set and test set. Now this particular technique is specific only to supervised learning algorithms. If you are using unsupervised learning algorithm or reinforced learning algorithm, we are not going to split the X into training set and test set. Okay, just to keep in mind, the training set is always way bigger or way huge than the test data. So while splitting our X and Y into training set and the test set, we usually follow the ratio of 75:25, but if we want to change the ratio, it is totally up to us. The default ratio is 75:25, meaning where 75% of the total data will be taken as the training data and 25% of the total data is taken as the test data. Another technique is feature scaling. What is this feature scaling? Sometimes what happens is that the scaling of the different columns in a data set is very different, in which the bigger values are going to suppress the smaller values. If we go back and look at the original data, if you look at the age column and the salary column and focus on the scaling of both of these columns, the age column is having 2-digit values while the salary column is having 5-digit values, showing the difference in the scale. Because of this, the salary column values will suppress the age column values, and we do not want that in our model. Because if we do this, if we do not scale them properly, the chances of error is way huge. Now if you look at the encoded columns over here, we have the values of 1 digit from the encoded column ones and zeros, then we have 2-digit values in age column, and then we have 5-digit values in the salary column, which is not a good thing. Here the salary column will suppress the rest of the column, so we need to bring them on a similar scale, which is done in the feature scaling steps. So these are few of the data pre-processing steps which we perform in ML programming. In the part B of the data EDA and data pre-processing, I will show you how we actually do these steps in the Jupyter notebook, and when I will solve these steps, I will also tell you the mathematical explanation of all of these steps. So thank you guys for joining us on Mentor Buddy. I hope that you know about the data pre-processing steps we have in our ML programming.